Hey, welcome back, guys. Today we'd like to talk about stationary points, and before that, I just want to say, based on our hard working, keep social distancing everything, and we can like slowly, gradually going back to our normal life. And yesterday, the state government just announced like we can do like around 5 people visiting, and you know, so 10 people gathering, something like that. And also today I received the news like school is reopening for the end of May, to ask the year 11, year 12 students going back. And also from June, I think most students are able to go back to school. So we are slowly getting better, and let's just keep this way and hopefully not getting any other like the data back, to revise the, I mean, steps we're doing. Okay. So let's look at this one. So 10C. 10C is like the stationary point. So the stationary point essentially just means the derivative equals zero, or I should say just like some special point we have over here. So if the stationary point, or if the first derivative is zero, it simply just means like the turning point, and also like the sort of like the B, this guy. This guy is just means like point of inflection. Okay. So again, it's just like a special point for us. So, and again, for 10C, it's just introduce you some ideas about what a stationary point is, and then the rest of them just do some calculations. Okay. So every time we see the stationary points in the final year exam, they essentially just ask to take the derivative and make the things be zero. The only example I want to emphasize here is example 14. The curve with equation y equals x cubed plus a to the x power of 2 plus bx plus c passes through the point 0.5 and has a stationary point at 2,7 find ABC. So at the first glance, we can directly find out there is a three unknowns a, b, and c, but we only have 2 points 0, 5, and 2, 7. So essentially, it's just means like uh, we only gonna have two equations, but we kind of need like three in total. So in such case, we need to look at the station point is 2,7, and what we can do here is station point 2,7, which satisfies the equation, but also the f derivative 2 is 0. Okay. So basically, stationary point tells us two information. First one, this point. Second one, derivative. Okay. So now we have three equations and we have three unknowns. We can solve it easily. Okay. And this is 10C, pretty straightforward. Now 10D. 10D, I think most of teacher will cover this topic in year 11, and we just quickly go through this one. The types of stationary points. So we need to combine with our C together. So first we call the A as local maximum, then we call B as local minimum, and we call C as point of inflection. So for A, we gradient is positive, then 0, then change to negative. So essentially means the original graph just increase first, then decrease. So we got the local maximum over here. And for B, essentially it means we got the left, sorry, we got the negative, so we got decrease, and then we got increase, and then again from decrease to increase, or from negative to positive, we got local minimum. But for part C, for the point C, it's both increasing or both positive, so essentially we will have the same gradient, so sorry, the same sign of the gradient at the left and right. So my point C is point of inflection. And my question here is, why do we just need to add the local maximum or local minimum, or the word local in front of the maximum or minimum? The reason is because it might be only the maximum for this part of graph, but may not be the absolute maximum or absolute minimum for the whole graph. So, which means like if I have a graph like this one, so this guy is my local minimum, this one is my local maximum, this guy again is my local minimum. But my maximum is over here, and of course my minimum is over here. That's why we're only adding the local in front of it. So it essentially means it's from one station point to another stationary point, to another stationary point. Then this guy is only the maximum or minimum inside of this interval, not the whole functions. Okay. So let's keep looking at it. This table things is help us to determine its local maximum or local minimum. Okay, you should be able to draw it, but essentially this one is not included in final year exam. But again, it's quite important for you guys to know this one and to draw it properly to know which is maximum and which is minimum. Okay, and let's keep going. Example 17, sketch the graph. So this is pretty hard to sketch, but what we know is this one is gonna be keep increasing, and we can find the stationary point. Then we realize it's just like stationary point of inflection. So that's why the graph is looks like this way. Okay, and for this part, by the behavior, this part is not really included in this course, but in your once you enter the uni, you can use this one to approximate any other signals and to get what you want. Okay, so this one is just like the things you should know. And this is 10D. So for 10E is what I said before, like absolute maximum and minimum values. So for this one, just make sure you find all the stationary points and you find all the ending point and then compare with them. So let's look at example 20. We have the -2 to 4, and which is a domain. So our relation fx or our function is x squared plus 2. So they ask us to find the absolute maximum and the absolute minimum of the functions. So essentially, some people will directly plug the number in, plug -2 in to get value, and plug 4 in to get another value. So in this case, we have to be careful, really careful, because our minimum might not occur in other point, or my maximum may not occur in another point as well. So in such case, what we should do is first find all the derivative equals to 0, and second, find all the ending point equals 0. Okay, sorry, find all the ending point and plug in. And okay, then the second step is compare the ending point. Third step is plug everything in to compare all of the which is the first step and second step. So in such case, our minimum is 2 and our maximum is 18. Okay, this one is really should be careful to get the minimum and the maximum values. So also for this one, again, this stationary point is not maximum or not minimum because our ending point covers the maximum and minimum. Okay, for 22 is just essentially to make sure that you consider the you consider practical meaning of the x and your volume to never give the negative numbers. Okay, this is a 10E. So for this class, we essentially just like cover all the information we need for any problem, which is decision point, determine the maximum and minimum. And for next one, we're gonna cover for the maximum and minimum problems, or about like the practical ways to do it. Okay, and hope this video is helpful, and see you guys for the next videos. Bye bye.